So, welcome to this year's Squeak seaside demonstration. Last year I've already been here and I did a general Squeak demo. And this year I want to do a bit more about one small part of what Squeak can do, and that's web development. I think in the last year's talk I had already a small demo about Seaside, but you really need to do a bit more to really understand what Seaside is about. So what I will do in this talk is, at the beginning I will show what I mean in this demo with web applications and what the general problems are when you are developing this. And then I will do a very short overview about what Squeak is about, with a focus on how to program with Squeak. This will be very short, and I fear it will be a bit too short to really understand anything, but we will try. In the third part, then, we will see Seaside in action, a very first overview about what you can do. There is a lot of stuff that we cannot cover in a 1-hour demo, but I think for a very first overview and a good starting point for your own playing with Seaside, it will be quite good. And at the end, I can show some examples and I will give some pointers on the web. We will see how much time there is left, so maybe it will be just some pictures and links. If any questions? No. So, a very simple web application. So I have implemented, of course, with Seaside, a very, very small and trivial application that asks for a number. Oops. And of course, it already expired the session. So it asks for a number and a second number, and then it will print out the result. So very, very complicated program. But the interesting thing is that for doing that with a web server and a web browser, there is actually a little bit of complexity behind it, and actually an astonishing amount of complexity, because the web server and the web browser do only exchange HTML. So you click on a link and you get HTML back. So you have no way of having a really stateful application. You need to really encode the state in every link that you click on. So there are many ways of implementing these kinds of applications, and this one is kind of a very simple example done in a trivial template-like system. I think early versions of PHP worked something like that, but I never used PHP, so I don't know. So the idea here is that we have HTML pages with embedded code that can be executed, and you can kind of easily access parameter values. So we have a first template called first.html that just renders the input dialog with a submit button. And the text input is then given over to the second script as a parameter called value1. So after rendering that and clicking on the link will be clicked on the second.html, and this is this HTML here. And here we see that what we need to do to be able to add two numbers together is to make a hidden field with that gets the value that we handed over as a parameter. Then we make a second input field with our OK button, and the link clicked on that is the third file, which is result.html, that is here. And this now will get two parameters, and we can just add them together to get the result. So this could be done in a template system, which would look something like that, or you could make a CGI script. So if there is no parameter, print out HTML like that. If there is one parameter, print out HTML like that. And if there are two parameters, just calculate the result and return the HTML for that. So for such a trivial program, this is quite a lot of work that is being done. To see how this works together with the browser and the server, we can look at it this way. So we have a user here who has a web browser, and we have a server that has the files. And the only thing we can do is we can just send a GET request to the server and get back HTML. And so we need to marshal all communications with the server into these links, that we call. That's not really nice, and quite a lot of work. So if we look at that and think about how we program normally if we write applications for a normal graphical user interface, then the control flow that we see is actually really strange, because we need to encode in every kind of call that we do over the web browser. We need to know where we came from and need to encode enough information so that we can go back to where we came from. So in a way, programming HTTP-based applications is a lot like the old GoTo programming. So we go to a new page, and we need to know where to go back to and where we came from. We need to marshal all the parameters by hand, and that's really a lot of work that we don't want to do. So we want to do it somehow, more intelligently. And I'm quite sure that there are already very interesting frameworks for the other languages. And I'm actually no specialist in how Java people program web applications or how PHP works in the newer versions. But what I'm sure is that I personally really don't care about HTTP at all. I really don't want that. And the other thing is, how do people debug this kind of stuff? I want to have, or want to use my really powerful debugging tools and not print out strings or some stuff like that. And the other problems is, anyone try to use the back button in that application? That gets really a problem. So what do I do? Or maybe you would want to copy the URL and have two browsers on the same application. So stuff like, let's see. Oops, I did not want to put 8, but maybe 5. Okay, and this should just work. I don't want to have to program that manually. I just want to have the back button work. So my programming system should take care of making the right stuff. Or if I now make a second browser, I want to have the same page, and I want to be able to just do something here, like that, or that here, so that both are now working in different directions. Of course, as soon as I do some kind of transaction, like if I order something in a shop, I want to have transaction semantics so that I can only order it once and the other sessions are automatically terminated. But as long as I don't commit to anything. I want to just browse around and I don't care about having only one browser. So that should be automatic. I really don't care about programming all that by hand. So in the end, the question is, why can't I write this program with back button support and with copying the URL in the browser? Why isn't that possible with 3 lines of code like that? So I have two variables, number 1 and number 2. And then I just say, please give me the first number, and I assign it to number 1. Please give me the second number, and I assign it to number 2. And then I just add those together here, make a string out of them, attach it to some nice string at the beginning, the result is, and just say, please print out this last page. And everything else should be automatic. If someone presses the back button, the program should itself go back, and I don't want to program that. And I don't want to do any HTTP decoding and stuff like that. And this is actually what Seaside is all about. So this 3 lines of code is, of course, the program that I showed you. And Seaside allows you to have the complete session as one piece of code like you would program a normal application outside of web development. I want to do, in today's web, be able to use CSS style sheets nicely, because it used to be that the designers did the HTML and the programmers did the programming, and template systems were quite nice for that. But in today's systems, people mostly use CSS as the design tool, and the HTML is quite static, so the designers don't need to change the HTML. I want to have a very nice callback-based event model like I know from real application development. I want to easily compose and reuse the stuff that I program. And I want to have really, really good development tools, like the one that I'm used to, and not printing out HTML if there is an error or something like that. And I want to show about all these 5 topics, some slides in the 3rd part. But before we can do that, we need a small overview about this strange language that is in Squeak. And this is, the language is called Smalltalk, and it is very old. So the Smalltalk syntax that you see here is from 1976, I think. And then it was forgotten, and it is now gradually be rediscovered. So if you look at Ruby, it has already 90% of it. So this strange Smalltalk is quite interesting. It's a 100% object-oriented language. Nearly everything is an object. So you can even do better today, but it's quite cool already. So for example, the stack frame is an object, numbers are objects, strings are objects, arrays are objects, classes are objects, methods are objects, everything. And so you can do really cool stuff. It is dynamically typed, like all good languages today. It is based on a virtual machine with a bytecode system, a bit like Java, and but simpler because you don't need types in the bytecode. It has a garbage collector, so you don't need to do it manually. It has a quite big class library that has a lot of stuff already done. Seaside is one example of that. And one of the most important things is the development environment and the debugging capabilities of the system. And this is actually where it is really a kind of advanced to other systems like Ruby or Python, as we will see later. The syntax of this language is actually quite simple. So this, you don't need to understand this now, but this Smalltalk on a postcard thing contains the complete syntax or an example of every syntax element in the complete language. So there is not much that you need to know. It does nothing, I think. So. But it's just an example that it is quite simple, the language. So if you take, for example, Java and take everything away that you don't need, you get this syntax. So in the end, you have only assignments and method calls, and that's it. And of course, you can write down some objects directly. So here are some examples. The first one is a simple method call. So if we have an object like 3, we can call a method, for example, factorial, and get a result. So in Java, you would, if you could, write this like that. But of course, you can't, because 3 is no object in Java. But I think in other scripting languages, it could work like that. So it's just a normal, of course, in Java, you would need to do it like that because it has no parameters. So quite simple. If you want to have a parameter, you do it like that. So you have kind of a speaking syntax, not a parenthesis at the end, very similar or the same as you have in Ruby nowadays. The interesting thing is that even addition is just a method call. So this here is a method that is called. This is an object, and it has one parameter 4, and it works. The other thing is that it has big numbers automatically built in, so quite nice. Now, the really strange stuff is that even the normal stuff like if and loops are mapped to method invocations. And this is what makes the language so simple, because you don't need any grammar for that. But it is a bit, you need to have a bit of, you need to get used to it. It really looks strange at the beginning. So the most important thing to know is that, for getting a bit of understanding, is that in Smalltalk you can write code without executing it. So if I type some code like 1 and put it into brackets, then I get an object that stands for the code inside without evaluating it. So it's kind of like a function. If I print that, it will tell me that it is something strange, a block, and lots of information we don't need. So we can actually ask it for the class, and we'll say block context. Okay. To get the value of the code inside, we need to tell it value, and then we get the value. Okay, which is 1, which is class small integer. So, and with this capability of putting code inside an object without evaluating, you can just make any form of control structure that you want. For example, here we have a method called ifTrue, and this is implemented on true and false. So if we have here one smaller 2 is true, and true implements if true. So to just return the value of the block that you give to it. We can actually look at the code. So it just says if true alternative block, and it just returns alternative block value. Quite simple. The same you can implement any form of loops. For example, we can just repeat something 4 times. I don't have my sound on, but it's not that important. Or we can do kind of database queries on collection structures. So if we use that syntax to write down an array, that's part of the grammar of the language, to have hash and this in parentheses. That's an array. We can ask it even. Array. And this understands select. And the select wants to have a block with 1 parameter, and it will just execute that block for each of those elements in the array and make a new array like a database query. So please give me all that are bigger than 1. And with that, you can, of course, program quite nicely. If you think about how many lines of code you need in something like Java for that, to have a loop, take it out of the collection, test and stuff. Oops. I lost my small thingy here. This object, which is a normal object, is just hopping around with me from page to page, and if I lose it, I have a problem. Okay. So Squeak is quite interesting because you can prototype very fast. It has a simple syntax and quite powerful semantics, no strange type system and stuff. And this means that it is used a lot for research, for example. And I put it first, not because it is the most important, but because I personally use Squeak for research and a bit for teaching. And we are quite, I think, successful, and most important, we have lots of fun using Squeak, because Squeak is completely implemented in Squeak itself. So the compiler, for example, that compiles this text to bytecode is implemented in Smalltalk, and you can change it quite easily and stuff like that. So it's really nice for testing new language features or stuff like that. Another thing that is done a lot is prototyping, which is a form of research, but they don't like to call it like that. So prototyping, people used Squeak to prototype stuff in industry and then implemented it in different systems, because you do not do products with strange stuff, but with C++. But for prototyping, it's quite nice because you can change it very, very easily, and you can do lots of iterations very fast. Another thing that is now coming is actually production with Squeak. And most of the production work that has been done is actually done with Seaside. And there is really lots and lots of interesting stuff being done in Squeak, both commercially and research, like, for example, Croquet, which is a 3D multi-user peer-to-peer environment, very interesting. The Squeak eToy stuff for programming in schools for kids around 10, which is a graphical system, so you can easily learn how to program. And then there is this, now I think quite famous $100 laptop, which will have Squeak included. But of course, mostly the eToys stuff. Or the Sophie project, which is the idea of implementing the book of the future, which is done in Squeak. Or a commercial project, which is done in Seaside. It's called DabbleDB. And this is quite interesting. It's a hosted service for doing what you normally do with Excel and BASIC. So database-like applications that are tailored towards certain uses. And this allows you to do it without programming. It's very, very interesting. This has been done by the guy who invented Seaside, Avi Bryant, and this is really, really cool. So I need to check how much time I have. Okay. So now we have a little bit of knowledge about this strange language inside. I hope that it is enough to kind of understand the examples. I'm sure it is not enough to go and start programming with it. But for just getting a bit of, not completely lost in the examples, it should be good. So I now want to give a short overview of Seaside. At first, a second very simple example, and a second look at the first trivial example. And then a bit about all these things that I already mentioned. So a bit about HTML and CSS, and about callbacks and composition, and an example of debugging. So the example that I want to show is equally trivial. No. And this is a very simple counter. So we can just count up and count down. So quite simple, but it is nice to show this stuff with then having two instances of the same program running into different directions. And of course, the back button, as it should. So if you press back, you get 2, and if you press plus, you get 3. And if the back button just goes back and shows the cached page, it would go back, show 2, and if I press plus, it would show 4, because the state of the server would not be backtracked. And in Seaside, it is backtracked automatically. What I want to show with this trivial program is a bit the tools that we have. So in deployment mode, of course, we would not have this bar in the lower pane. This is just for doing some stuff while developing. For example, we can check how much memory it uses. So, or we can do a profiling to see if it's slow to render, where it takes its time. and it even does a bit of memory. And shows maybe it's slow because it does 50 garbage collections, so we see that too. And the most important thing are the halos. So we can press toggle halos, and it wraps our component into a halo that shows some tools. One thing is that we can here toggle to see what kind of HTML it generates. And these links actually work. The other thing is that I will show in a later demo how to use that is the CSS editor. So you can change the CSS style sheet for each component individually over the web interface. Then there is a very nice inspector so that you can look inside your objects. So for example, this WA counter object that is rendered on the screen has a state, of course, the counter, and this is right now 3. So, and if we make it one smaller, we'll see that it's 2. So we can very simply look inside our domain model, so first the presenting model or the domain model of our system. Quite nice if there are bugs that you don't understand. And then there is a small button for getting the source code. For that, we need to make it a bit bigger. And there we see how this thing is implemented. So this counter is its own class. It's a WA counter, and it's a subclass of a WA component. Like every visible thing in a seaside application that is rendered on the screen, it's a subclass of WA component. And it has one instance variable named count. And the rest, so here we have just some pre-sorted classes so that we don't have a list of 2,000 classes, but we have only the seaside examples test classes. Here are all the classes of that kind, and we look at WA counter, and these are the methods inside. So for our instance variable, we have an accessor that just returns the value. We have an initialize method that is called whenever the object gets instantiated, and that's, of course, sets the counter to 0, and it registers the object for the backtracking stuff, so that that seaside knows that if you press the back button, that this state should be go back one step. And besides that, we have decrease and increase methods that just change the counter. Quite simple. So count. This one should be like that. The underscore is the same like the old way of doing assignment in Squeak. And the most important method in these components is the render content on method. And this generates the HTML that you see on the screen. This method gets as a parameter an HTML object. On that, you then can call methods like heading or this anchor with action. And here we see that it is actually quite powerful because we can use these strange blocks, these code that is not executed right now. We can just say, for example, to this anchor that as soon as someone presses it, it should execute this code. So as soon as someone presses the ++, it should call self-increase. As soon as someone presses the --, it should call self-decrease. The example we have seen directly at the beginning, the two numbers added together, is working like that. So if we look at the class, which is now called add numbers, this is a subclass of WA task. And WA task is a bit like a component, just that it is not rendered on the screen. So you have, for all your applications, you will have one task, and this encodes the control flow of your application. And then it uses components to render them on the screen. So the method that is called here does not need any parameters, so it's just named go. And this will just be executed, and it will use other components to do the rendering on the screen. For example, here it will call request and inform, which use WA component subclasses to do what they are supposed to do. Okay. So we have seen a WA component which uses the render content on method to implement what to show on the screen. We have seen WA task example, our first example. And so what should be remembered from that is that the components are a bit like widgets in a widget set. And the task is the control flow of the application, so the application itself in a way. We will see examples for that later. One thing that I will not have time to really talk about is the way the components interact with each other, because that needs a bit more explanations of the deeper things. What you should know is that a component can be shown on the screen by using a self-call with a parameter, and the parameter is the class or the object that you want to show. And this component then, at some point of the execution, it can just say, okay, now I'm done, and then it returns back to the exact point where I called the call method. And this is used, for example, in the request and inform. But before we look at that a bit closer, I think we should look a bit about at the HTML and CSS stuff. So the idea of the current Seaside version is that we have a framework for generating XHTML. That's what the programmer does, and the designer has to do the CSS and only the CSS. In early versions of Seaside, we had a template system, but it turned out that as soon as people switched over to CSS, that they really didn't need any templating anymore. So the template system is there, and everyone is invited to hack on it, but somehow it is not actively maintained anymore. So for those who are not yet convinced that CSS is cool, they should have a look at this CSSZengarten.com webpage, which shows what you can do with just changing the CSS without changing any HTML at all. And if you are really not convinced, there is a templating system that needs a maintainer. So the idea of this XHTML building is that you have this HTML object that you can call methods on. For example, you can make the HTML shown here with div and span for a list, by just using this code. So it looks very much like the HTML, just that you do not have as many brackets and strange XML stuff. So as soon as you have this code in your render content on, Seaside will make sure that this HTML is rendered to the browser. It gets only really interesting when you start to mix that with calling methods inside this code. So here is an example that just renders a button that you are supposed to press, and then it says hi. We can have a look at that. I think it's that one, yeah. Say hello, I press the button and I get hi, and I can press again. So very simple. And this works in the way that we have this submit button with action and text, this method that we call. The text takes, the second parameter is just the text that we want to render, and the first parameter is an action block that gets evaluated as soon as we click on the link. So as soon as we click, Seaside will invoke the code for self-inform hi, which invokes another component, replaces the current page with that and makes sure that when we press the button again, that we are back at where we started. So if we say hello and press on OK, we are back in the code again. And this gets automatically rendered into the HTML we see down here. And Seaside makes sure that everything works like we want to do. We do not have to do anything by hand. So just that code, and it will just render it to have two hidden fields, which is the current session and the current ID of where the program is in its state. So if the link that is rendered has that you click on gets this information to Seaside, and Seaside knows what it has to do. So if it gets this session ID and this program ID, it knows, oh, I need to evaluate that block. Completely transparent. You don't need to actually know what it does here. Gets really interesting when you want to do stuff like, I show you the second example. I think it's example callback 2. Yep. So this wants to have a username. So I press say hello, and it will say, hi, Marcus, which is a bit not right. So we can actually change a bit the code to make here an okay. Yep. Now it has even here the space. So this works by using a callback. So we render the text normally here. Please enter your username, and then we say, I want to have a text input field with a callback. And as a callback, I give a block that has one parameter, and the parameter gets the value from the input field as soon as I click OK. And then it executes the block, and in that block, I just say username, which is an instance variable of that object. Please set it to the value that you have, and then I can just use that username variable in my action block that does the inform without having to do anything manually. So all the pages that I generated, or not generated, that are done correctly without me doing anything for it. One thing that is quite important is that I want to have multiple components on one page. And I actually don't want to specify anything by hand when I use the component and change the state. So let's look at an example of that. Here I have just our trivial counter example rendered 5 times. So I can go with all those in different directions. I can actually even toggle here the source and go down here. And everything is done completely automatic. And how do I implement that? So the idea of those components is that you can render components as sub-components on one page. So the multi-counter is a normal subclass of component. And we just added 5 WA counter objects to a collection named counters. And the children accessors just returns that collection. And now we can just render them on the screen in the render contents on. And we do that by just saying, okay, all our counters, please do the following code. So for each counter that we have in our collection, we say our HTML renderer, please render this component. So HTML render our component. And between all those, please execute HTML horizontal rule, which makes the this rule here. So quite simple, and the interesting thing is that I did not program anything about that the state is different in all those components and that I can go up here and down here, and everything is automatic. So as soon as I render a component to the screen, the system will do the right thing. And this makes it actually quite simple to build very complex applications with that, because you can just build your widgets for the screen as components and then render them on one page, and the system will make sure that the control flow is working correctly. So we have already seen that the control flow is kind of natural, like you would expect it in a normal GUI application, like if you program a GNOME application or something like that. Pages in this system can be called like subroutines. So you can just say, oh, I call my component, and the component returns a value, and it can just store it in an instance variable and stuff like that. Components can even register callbacks that gets executed when I click on something. So overall, this is a step into the right direction, I guess. We escape the go-to hell of normal HTTP-based programming. And the back button works. Of course, we need to take care that it works correctly. As soon as we do not want to have it enabled, we need to have something for it. And to show how this is done, I will show a small demo of a very trivial web shop that is part of Seaside demos. This is the store. This is a very, very simple internet shop where we can buy sushi. So okay, quite simple. One thing that we can show here very nicely is the stuff with the CSS. So here, let's go back. We toggle the halos, and we get for all things on the screen, we get a halo. And this WS store fill card is this one here. And this has some CSS. So we can actually change it like light gray. Let's make it red. Okay, so works. And we can show nicely how the control flow is implemented in this application. For that, I will take a normal systems browser because it uses the task. So it is the control flow uses a task object, which is not rendered directly on the screen. So a bit bigger. WA store task is the class that is the main class of the store. And there we have a go method that implements the control flow of our store. So at the beginning, we make a new store card. And then we say isolate. Isolate means from that part on until we close the bracket. So here is a starting bracket and here an end bracket. We have one transaction. So if you go inside it, you cannot go back again. So the back button is disabled at the point of entry, and it is disabled at the point of going out. So as soon as we go out of that code, we cannot go back into because the transaction is done and we cannot do anything. So it just calls self-fill card, self-conform of card, and this is done as long as the confirm does not return true. And then we need to do the shipping address and get the billing stuff. And here we nicely see that we can call pages like we call a subroutine in a normal system. So, for example, the shipping address is an object returned by self-get shipping address. And this builds up a whole stream of pages, but it will return just with one object, very easily. So if we look at the code, it's a bit, so it calls get address with message. And this uses now self-call, to call another component, which is the WO store address editor. So it now hands over the control flow to that one. And this will, at one point, return with the complete address stored into an object. And at that point, it will return that from the call. I think that was everything I wanted to show with the sushi. Problem is time is running short. One nice thing is that you can here nicely see that this inspector is quite nice. So we can go into the card, and it has items, and the items are 3, and everyone is a store item, and the store item has a title, a subtitle, and a description. We can nicely go back. So it's quite nice for debugging. Okay, that was the sushi shop. The last thing I want to show about this system is the way you can debug and change it while it is running. We have already seen that we can at every point go to the code that implements this thing that is rendered on the screen, like in this kind of store item view. We can change it at runtime without having to restart the server. We can do it from within the browser. We don't need to do it from within the browser. We can do it from within Squeak, just what we want to. The browser is nice if you have a deployment situation where you cannot get to the image. So normally, of course, you have access to, don't know, forwarded X11 or something like that. But if you don't, you can use this small built-in web-based programming tool. You will not use it for programming 5 hours a day, but for small stuff, it is okay. We have seen that we can change the code at runtime. No need to restart the server or restart the program, so all data is valid. The customer is on the phone, and you just say, oh, try again, and it works. And that's very powerful. Another thing is that we can at each point make a breakpoint in this code. So for example, it could be that we make an error here, so we forget this dot. Okay, we save, we close, and now it should actually, we should get an error at some point. We don't. Let's do an error here. Okay, so we got an error, so our application blocks, and on our development environment, which is the thing that I use instead of PowerPoint, we get a dialog that asks, what do you want to do? And I say, oh, I want to debug that application. And I see, okay, I did a breakpoint here. At that point, I can see all the information of my program. I can see that there is a card and that it has an item, and I can see which item it is. It's Nakamaguru, okay. And I can actually, when I see what I did wrong, like adding a breakpoint here, I can delete that, save it, and can say, okay, please continue. And this will continue the program without stopping anything. Though the normal program is now running. As we see, the nice side effect is that it did render 2 times, which is a bit strange, but it works. So we can edit our program, debug our program while it is running without terminating anything. Okay, so if I look at the time, I think there is not too much that I can show besides that. I did not show too much, so there is a lot of really cool stuff like database access. I did not talk about anything. Seaside testing, a testing framework for testing seaside applications. Then Magritte and Peer, very interesting. Magritte is a meta model for describing your domain objects, and then it will render automatically to seaside. Or a component library with predefined components. And of course, Ajax and Scriptacular support is there. But we have sadly no time at all to look at that. I will put these slides online and actually the complete image so you can play with it yourself. And there are some links for you to look at. So there are some example applications. Squeaksource.com is written in Seaside. There is, for those who understand German and I think French, a Swiss application for getting an offer for a health insurance company, which is completely implemented in Seaside and available for everyone to play with. And then DoubleDB, of course, which is not yet publicly available. Very cool, completely implemented in Seaside and running on Squeak. And if you want to learn more, there is about Squeak itself from the hacker perspective, so programming with Squeak, for example, Seaside is squeak.org. If you want to use Squeak to learn programming, if you are younger or if you have kids, then squeakland.org is good. And then there is a German Squeak association, squeakev.de. And Seaside itself has a nice website, seaside.st. There are videos and an image to download and documentation. And that's it. Are there any questions? The question was if there is anything about security, like encryption and stuff. So encryption there is a library for encryption available, which implements lots of stuff, hashing things and encryption itself. Besides that, there used to be some network intrusion tool that was done in Squeak, but I don't think that this has been developed. But inside Seaside. Permission management for components. Seaside itself does not have that. You have a session management. The peer system has a fine-grained user management. So peer is a system built on top of Seaside that it started as a wiki implementation, but it is more kind of a new layer on top of Seaside. And this has user management and security management. Any other questions? Okay. So thanks.